The very last part of our scattergraphs work is being able to determine and use the equation of the line of best fit. We've already looked at how to create a scattergraph and how to draw the line of best fit. Now, you're probably quite unlikely to be asked to do either of those things in the exam. You're much more likely to get a question along the lines of, here's a scattergraph that's already drawn, here's a line of best fit we've already drawn, what's the equation of that? And then it might ask you to go on and use that equation to do something else. So let's have a look at this first example here. The first example says the following scattergraph shows the history and geography scores as percentages for a group of pupils in S2. So geography up the, what would normally be the y-axis, we've got a little g for g-axis here, and history scores along what would normally be the x-axis, but we've put an h at the end of that for history. And each one of these crosses represents one of those pupils in S2. So for instance, this little cross down here represents a pupil who scored roughly about 22-23% in their history test and 20% in their geography test, whereas this cross up here represents a student scoring 70% for history but only 40% for geography. What you can see here is there's a rough kind of correlation here, a positive correlation between the history and geography scores. Most of the data is kind of going up in this line with the odd outlier. Now, the question we're being asked to do here is from that scatter graph, which I'll try and leave in view there, is 1, determine the equation of the line of best fit. In other words, think of it as just a straight line question or the equation of a straight line question. What is the equation of this line here? And then for part B, use your equation that you've created to estimate a pupil's geography score if the pupil scored 54% in history. And that's what we can use this line of best fit for here, to help us to estimate one value if we know the other. So if we have a history score, we should be able to estimate what a likely geography score should be. And if we have a geography score, we should be able to estimate what a likely history score would be. Let's start off though with part A, and where we're going to determine the equation of the line of best fit. Now, the equation of the line of best fit is a straight line equation. So for straight line, we're going to put our 3 headings in. So I'm going to need to find the gradient. I'm going to need a point on the line. And I'm going to need to then write out the equation. So 3 headings. When I'm trying to find the equation of a straight line, these are 3 headings I want to use to kind of help me. Now, to find the gradient, I'm going to need to use the gradient formula, and for that I need 2 coordinate points. Now, there are lots of pieces of data floating around here, but I can't use this as a coordinate point because it doesn't lie on my straight line. And the points I use don't necessarily have to have crosses at them either. What I'm looking for is 2 clear and easy to read coordinate points that sit on this line somewhere. So one that I could use straight away, it would be quite an easy one to pick out, would be this one here, which is 0 along, 15 up. So I'm going to write that above gradient here, or below gradient. So 0, 15, that is one coordinate, 0 along, 15 up. And then just look for another point somewhere on the line. As I said, it doesn't have to have a cross at it. So we could use this point here, 10, 25, or I could use this point here, which was, say, let's say 45, 55. Let's just use that, 45, 55. Now, that's all the information. That's all I actually need this graph for here at the moment. I might come back to it in a minute, but let's try and move all of this up. So, from there, really all we're doing now is trying to find the equation of a straight line from 2 coordinate points. If I start that off, what I'm going to do is write out my gradient formula. So, gradient m equals y2 minus y1 over x2 minus x1. If you've forgotten which is which, it's a good idea just to say underneath those coordinate points you've written, write out x coordinate, y coordinate, and bracket 1 and bracket 2. And then I can substitute them in. It doesn't do any harm to do that, it just costs you a couple of seconds. So y2 take away y1 is 55 take away 15, and x2 take away x1 is 45 take away 0. That's going to give me 40 over 45, which I should really simplify down to 8 over 9 by dividing top and bottom there by 5. For the point, it doesn't really matter which of these 2 points you use. We'll just choose this one because it'll maybe make it a bit easier because of the 0. So I'm going to put in 0, 15 as my point. And then my equation of a straight line is y minus b equals m bracket x minus a. Now you might be thinking at this stage, why am I using y and x when the actual graph up at the top had a g and an h axis for geography and history? Because I'm used to using this formula, I'm going to continue to use this formula, and I'm going to replace the x and y right at the very last step. I'm not going to do it just now because that could become confusing. I'm going to leave it as x and y, what I'm familiar with, and then I'll change it out at the end. So y minus b, remember these are my a and b here, so b is 15, so it's going to be y minus 15 equals, and the gradient is down here, 8/9, so m is 8 over 9, bracket x minus a, and remember a is this point here, so 0. Substitute that in, and then start to try and simplify. So y minus 15 equals 8 over 9 x, and I could maybe just bring this across, this 15, so y equals 8 over 9 x plus 15. Now, it's absolutely fine to leave it like this, there's no harm in that at all. This is almost finished. I have an equation for y in terms of x, but if I remember back up to my diagram, let's see if I can see what that looks like. You'll remember I have up here an h-axis for in place of where my x-axis usually lies, h for history, and I have a g in place of where my y would usually sit for my y-axis. So I'm going to replace the y with a g, I'm going to replace the x with an h. So let's zoom back in there. So the y gets replaced with g for geography, 8/9, x gets replaced with h for history, plus 15. What that gives me is it gives me a formula I can then use. This is the equation of the line of best fit, but it also tells me if I know somebody's history score but they missed the geography test, I can probably work it out by substituting into this. So basically most people's geography score is equal to 8/9 of their history score plus 15. It's a good way to kind of calculate these values. Now, part B, it says use your equation to estimate a pupil's geography score if the pupil scored 54% in history. Now what you might be tempted to do at this stage is to go back up to your graph here and look at your line of best fit. In previous years you would have probably used your line of best fit like this. So 54% in history is roughly about here. You go up till you hit your line of best fit and move along to here and you get about 64% for geography. We can't do that in this question because the question specifically says use your equation, which means we have to use the equation we formed down here. So because we formed this equation down here and the question specifically says use your equation, we must use this as the basis of our working. So for part B here, I'm going to write out the equation. Geography is equal to 8/9 times the history score plus 15. And I'm going to look at the question again where it says use your equation to estimate a pupil's geography score. So in other words, find G if the pupil scored 54% in history. In other words, if the history score was 54 or H is 54. So we know here H is equal to 54. So that means the geography score is equal to 8/9 times the history score of 54 plus 15, which I can then just type into a calculator and I end up with 63%. And then I'm just going to answer that in a sentence. So I would expect the pupil to score 63% for history. Now remember, that's just an estimate. It doesn't mean that pupil would actually go on to score 63% in history, but we use the line of best fit to estimate or make a best guess. So the equation of the line of best fit does the same job. Remember though, if the question says use your equation, you must actually substitute into the equation you got for part A to be awarded any marks. You should also remember that I can also use this equation in the other way. So for instance, if I was given the geography score and asked for the history score, then I would just substitute in place of G. What I'd end up with then, rather than just something to evaluate, I would end up with an equation which I could go on and solve to find the history score.